to go through rational exponents. Because they give people trouble just kind of on their own, and then they also come up in logs. So definitely worth discussing. All right. So if you get something that is like, let's say, x to the a over b, you got a fractional exponent up there, that's an a. That number on the bottom is the first thing you're going to do, and that's it's telling you to take the b root of whatever is going on there, and then the second thing you do is raise to the power on top. Also keep in mind just general tips here, negative exponents. Flip the base. To get rid of an exponent in an equation. Raise both sides to the reciprocal power. And I will do all of these things. Just trying to give you a little sneak preview, advanced summary type thing here. And then a third note would be if I have like the b root of x to the a, that's the same thing as x to the a over b, where this fella here goes first, and that's the root, and then this one here goes second, and that's the power. So that's a lot of information quickly. Sometimes I probably go too fast on the videos, but in my head I'm like, oh, well, I could just pause and rewind if they need to, so I will try to go slower. I know that I don't do a great job of that. I guess I'm just kind of apologizing if you have to rewind, but that's not that big of a deal. All right, so let's start going through some examples of the stuff I just wrote notes on there. So let's say, a to the negative 2/3. You got to fix that. You got to simplify that. I cannot have a negative exponent in my answer. So that's one of the simplifying rules in this class that comes up. Not every time, but typically you don't want negative exponents when you're working with something. So there's kind of 3 steps I'm doing here, and I'm going to write them all out. The first, maybe a couple I do, but then I won't be writing out in detail as much after that. So the first step here is take the third root of 8. And so that's what number to the third power gives me 8. So what number times itself gives me 8, and that's 2, because 2 times 2 times 2 gives you 8. And the second thing you do is raise that, whatever you just had, to the second power, not because that was a 2, but because that was a 2. So 2 squared is 4. And the third thing is flip, because exponent is negative. So the answer here would be 1/4. If I were to just talk through that, start at the bottom. That tells you to take the root, so you're working backwards. Think backwards in your head. What number cubed gave me 8? That's 2. You take that 2, you raise it to the power on top of the fraction. 2 squared is 4. If it were positive exponent, you'd be done. If it's negative, you flip over your answer. Let's say 1/25, 1 over 125 to the negative 3/2 power. So there's a couple things going on here. You got a fraction on the inside, which we didn't have in the first one. I guess that's the only new thing. And what I would do here is I can get rid of the negative exponent at any point that I want. So I'm going to flip it right away and say, well, that's just 125 to the 3/2. So don't flip the exponent. The negative exponent was removed, so the base flips over. The same way as if I put a negative exponent back in, going this way, the base would flip over. And then talk through this process again. So what is the second root of 125? That is not going to work. We're going to pretend this has been 25 the whole time. So just pretend. All right, so what was the second root of 25? So what is 25 square rooted? What number squared gives you 25? So that's 5. And then you take 5 to the third power. And that's where I had 125 from. If this exponent were negative, your answer would be 1 over 125. Now let's say 36 over 49 to the negative 1/2. So again, if there's a negative outside a fraction like that, I think the first thing I would want to do is get rid of it and say, well, this is really 49 over 36 to the 1/2, and then I'm applying this fraction to both pieces in there. So what is the second root of 49? Is 7, and then 7 to the first power is also 7. What is the second root of 36? And then 30 is, which is 6, right? And then 6 to the first power will give you an answer of 7/6. Even this one I did here is a to the negative 2/3. Let me just do it again. Let's say that you just decided every single time I'm going to get rid of the negative exponent first. Well, you would just make this, if I make the exponent positive, the base flips. So you could have done this in that order also. Then you would go, okay, well, now I'm going to do it to the top and do it to the bottom. 1 to any power is always just going to be 1, because watch what happens. What's the third root of 1? What number times itself 3 times gives me 1? Well, guess what? That's 1. Now take the 1 and square it. So you multiply it by itself. Well, guess what? You're still at 1. So I don't care what you do with powers to 1, it's always going to be 1. You just multiply by 1 in different ways. On the bottom, the third root of 8 is 2, and 2 squared is 4. So we get this 1/4, and it's just showing you a different way. Your brain might process in a different order than mine does, or someone else's, or whatever. 4, let's say. So let's throw this in an equation. The fourth root, and let's do a radical thing. The fourth root of x to the third equals 27. So the first thing I got to do is remember or realize this deal here, this rule here. So you always go inside over outside. The inside power goes on top. The outside power goes on the bottom. So this, the first thing I'm going to do is rewrite this as x to the 3/4 equals 27. And then this is that note that I was saying. To get rid of an exponent in an equation, raise both sides to the reciprocal power. So the way I get rid of a 3/4 power is raise that to the 4/3. And there's a reason that works. When you have a power raised to a power, what you're going to do is multiply. So first of all, I have to do it to the other side also. But what I'm going to do is multiply. Well, what's 3 times 4? 12. What's 4 times 3? 12. So you just got x to the first, which is the whole point. That's what we're trying to find, right? So that's why you raise to the reciprocal power. I don't really need this 1 here. It's just x. And then 27 to the 3/4. So work through your process. Root it. So third root of 27 will be 3. 3 to the 4th power is 81. All right, let's look at another one similar to that. I'm looking through your worksheet right now and trying to grab something similar. Let's say x to the negative 3/2 equals 64. No, 1 over 64. So there's your problem. So you got to find x. This is a fraction, but that doesn't really impact the way we do the problem. It just makes your life a little more annoying. But I'm going to do the exact same thing I just did up here. I want x by itself. Right now, the issue is there's an exponent there. I don't want it. So I'm going to multiply by the reciprocal. So the reciprocal of a number is the number that when you multiply it by the other reciprocal, you get 1. So if the exponent is negative, and you want to multiply by the reciprocal is negative also, because when you multiply them together, you have to get positive 1 for your exponent down here. So that's why I chose the negative. Now I'm going to go through this, and I got to do this. And so some people, I think it's probably easiest to, you got a negative exponent. So if I get rid of the negative exponent, the base flips over. So I would rewrite it like that. And then think through what's going on. So the third root is 64. So what number to the third power gives you 64? That's going to be 4. And then 4 squared gives you 16. So this should really help you with the rational exponent practice. And it should help you with the logs too, I believe.